Okay, so in question 4, we're using the property that if we have a median and we construct another median here, then if we draw a parallel line parallel to the base here, so that these lines here are parallel, then we have a ratio here of k is 1/6, 1/6 I should say, and also that this blue line here has a special name called a mid-base, so it breaks this in half. So if k is 1/6, then if half of that would be 3k, and then we also know that the ratio of this point here from the centre of gravity to the lower part here is 2:1. So if this is 4k, half of that would be 2k. So we're going to use this property here in this example. So we can see, let's take the median line here first. Let's look at the parts that are important to us. BL is going to be important, and also GK is important. It's a little bit tricky to see on the diagram which part goes with the 4 here, so let's use colours. GL is the line that's 4, and DG is 6 here. So that part there is for the 6, and this blue length here 4. All right, so well, let's look at the first median we can see, which is BE. And so BE, we're looking at this entire length here. So if that central part, so we've got here that these lines are parallel. So let's do the parallel parts in blue. EF, actually let's use the one that's relevant to us here. DF, this line here, is parallel to AC. So now we're using our pattern here. 4 is the 1/6, so this top part here, which we're interested in, is BL. That must be 3 times that, so that must be 12. So we've got the first part here, that's 12. So now to look at GK, we're looking at this. Let's use a different colour. Let's use this for CD. So this median here, CD, we can use that same pattern of 3k, k, 2k. So the 6 corresponds to 2k. So GK is going to be half of 6, which will be 3. And so if we add those two together, we have our corresponding here length. Because these are lengths, we should include the units of 15 centimetres. So that was question 4. Let's have a look now at question 5. In this case here, we're told that D, E and F are midpoints, which means that all of these side lengths here are bisected if these are midpoints. And also E, we're also told that. But let's just use this bit of information for now. What we should be able to see is that they have, if we consider 2 triangles here now, let's draw them here. If we consider triangle AFD and triangle ABC, we can see that they're similar. They're similar because they have a common angle here, angle A, and the sides are in the same proportion. We've got 1:2 and also 1:2. So that ratio is equal. So we should write correct notation for that. If you're happy with this, you can feel free to fast forward the video, but for the this is important that we get the notation right. So we've got ADF, triangle ADF, similar to, so that's just the squiggle here for similarity. A corresponds to itself in the next triangle, D corresponds to B, and F corresponds to C. We need to also include our reasoning here, which is the similarity reasoning. The angle is equal, and the 2 sides on either corresponding side are in proportion. All right, so what this means is we've got the DF, which corresponds to BC. This must have the same ratio as the other sides. So for example, let's take in the small triangle AD, so the corresponding side in the larger triangle would be AB. And so this ratio here must be 1:2 because AD is half the length of AB. So what we can say here is that if we call this A, then this whole length across here must be double whatever that inside length is. So we can do that same process repeatedly for every triangle, maybe starting from angle C instead as the common angle and then using angle B. And what we'd see is that this length here, let's call it C. This length here would be 2C. And if we take, and I'm running out of colours here, if we call this side B, then this side AC must be 2B by using the same logic. And so what we can say actually is that the inside perimeter of triangle DEF, which is A plus B plus C here, and the perimeter of the outside triangle is, well, double all of that, 2A plus 2B plus 2C. And actually what we should see here is that the ratio of the perimeters also is 2 to 1. And so we can see that the ratio of the perimeter of the large triangle to the perimeter of the small triangle, if we have the midpoints, is actually equal to 2. Well done, I hope you enjoyed that video, and I'll see you in another one.